Hiya folks, so this is differentiating trigonometric functions. So the three basic ones are, so the differential of sin is always cos. So anytime you're going to differentiate sin of something, you'll change it to cos. Anytime you differentiate cos, you're going to change it to minus sin. So the minus is important to remember. Then when you're differentiating tan, it changes to sec squared. So the tan one, that's not as common, so you won't have to do tan as much really in general. Let's just look at these examples. Yes, I'm going to say the other thing is with these you'll have to generally do chain rule. So if I was to differentiate, I'll just make something up here, sin of, and we'll just say it's 2x plus 1 or something like that. So really we have to use chain rule here. So look back at how to use chain rule if you can't remember, but that's when it's like there's something within a function. So it's like the 2x plus 1 is inside the sin part. So it's sin of something, but then there's a 2x plus 1 in there. So you just have to remember that you're going to use chain rule. So if I was differentiating that, so if that was y and I was finding dy dx for that, it would be, well, the differential of sin is cos, so it'll be cos, and then I'm going to of just the 2x plus 1, okay, so it's just cos of that, but then I'm going to multiply all of that by the differential of what is inside, so similar to chain rule. So the differential of what's in there would be 2. So then that would be my answer. I could put the 2 in front, so it would be 2 cos 2x plus 1. So if there was something else in here, it would be times the differential of the something else. And it's the same with sin. If I was differentiating y equals, I won't do it, but if cos of something of x squared plus 3 or something like that, it would change to minus sin and then multiply that by the differential of what is inside. So that you just have to remember that really with trigonometric functions. You'll have to do it all the time because you're never really going to be just asked to differentiate cos x or just sin x. So let's look at the examples here. So first one, y equals 3 sin x plus 2 cos x. So this is a nice simple one. So dy dx will be equal to, so the differential of sin is just cos, so it'll be just 3 cos x. Now I would multiply by the differential of what is inside, but the differential inside there, if I was to differentiate x, it's just 1. So it's just going to be 1 times the 3 in front, so it won't actually change. So it'll just be 3 cos x plus 2, and now I'm going to differentiate this cos x part, so that will change to minus sin, because cos always differentiates to minus sin x, and then you can multiply that then by the differential of what is inside. So again, it's just 1 because it's just an x for this one, so this one's a simple one. But if there was, say, an x squared in there, or if there was a 3x plus 5 or something in there, or anything, you're going to multiply by the differential of that. So anyway, just tidy up this one. That'll just be 1 times 3. So that's just going to be 3 cos x. And now it's going to be minus 2 sin x. And that's it. That's all you have to do. So that's dy dx there. Second one, so y is equal to x squared sin x. So what you should see here is that it's one thing being multiplied by another thing. So there's an x squared and then there's a sin x. So you have to use the product rule here. So u and v. So the product rule is u dv dx plus v du dx. Right, so u, anyway, that's just going to be x squared. I'm going to multiply that by dv dx. So the differential of sin x then would be just cos x. Plus v, I'm just going to write down what v is. V is sin x. Just put brackets around it because I'm multiplying it now by du dx. So the differential of u would be just 2x. So I'm just going to multiply that by 2x. So now I've got x squared. I should have dy dx here actually. So x squared cos x plus, it'll be 2x sin x. And that's it. That's the final answer. Right, a few more examples. This one now, so we're going back to kind of what I was saying at the start there. So cos, so the differential of cos anyway is minus sine. So dy dx is equal to minus sine of 7x minus 3. You just put in whatever is there, you don't change it first, but then you multiply it by the differential of what is inside. So the differential of what's inside there is 7. So that will be multiplied by 7, so it'll just be minus 7 sin of 7x minus 3. And that's it. Right, now here it gets a little bit more complicated then. So you've got tan squared 3x. First of all, anyway, that's the same thing as tan of 3x all to be squared. It's just the way it's written. They put in the little squared there because if you put in the squared over here, it will confuse things because it might be just the x that's being squared. So that whenever you have little tan squared of anything, that means it's all just being squared. So complicates things a little bit. So if y is equal to tan 3x all to be squared, we're actually going to have to do this. It's like we're doing the chain rule twice here. So if I was to differentiate as normal anyway, dy dx will just be 2 because I multiply by what's in front, so it's all being squared, so I just multiply by the power, so 1 times 2 is 2, and then tan 3x, and then the power, like it would now be power to the power of 1, but that's just the same thing as just tan of 3x anyway. So now I have to multiply by the differential of what is inside, but inside that squared bit there is all of the tan 3x. So I have to go and differentiate tan of 3x now, and that would be sec squared of 3x, but I must multiply that by the differential of what's inside the bracket in here. So it's like I'm doing the differential twice, and what's inside there is 3x, so the differential of that would be 3. So that's complicated. So if you look back at the start again, there's something being squared, but then inside that there's a tan, and then inside that there's 3x. So it's like there's something within something within something. So when you do that, you find the differential of, and then differential of again, and then the differential of the last thing that's inside. So that's going to be our answer there. So 3 times 2 is 6. Tan 3x, I'm just tidying it up here, sec squared of 3x. So that's it. The last one then. So we've got something similar here again. So you can see it's being cubed here anyway, so it's sin. So y is equal to sin of x squared plus 2. And that's all being cubed. So because it has a little cubed in there, that means it's all to be cubed. So let's just bring the power, multiply by the power. So there's a 1 in front of that, so it'll be start with a 3 anyway. So dy dx equals, so it'll be 1 times 3 is 3, and then just reduce down the power, so it'll be sin of x squared plus 2 all to be squared now, and I can just put the little 2 in here. I'll do that on the next line. But now I have to multiply by the derivative of what is inside. So what's inside here is sin x squared plus 2. So what's the derivative of sin x squared plus 2? So again, I have to use chain rule now for just the inside bit. So that will be, the differential of sin is cos. So, So cos of x squared plus 2. But now I must multiply by the differential of what is inside that. And what's inside that is the x squared plus 2 bit. So now just focus on the x squared plus 2. What's the differential of that? It will just be 2x. And that will be it then. So we've got 3 sin squared of x squared plus 2 cos x squared plus 2 and 1 multiplied by 2x. So you can take the 2x and the 3 at the start and multiply them by each other, so you'll get 6x, and then it's just sin squared x squared plus 2 cos x squared plus 2. And that's the final answer. So there's a few here if you want to have a look at them. So you'll have to differentiate some of them in different ways. If you want to have a go at them and then play on the video, and I'll go through the answers. Right, so the first one, sin. So dy dx is equal to, so the differential of sin is cos, so that'll be cos of 2x plus 3, and then I must multiply by the differential of what is inside, so that's just going to be 2 in this case, so multiply all that by 2 equals 2 cos of 2x plus 3. That's the first one done. The second one, it's tan of x squared. So this one's not too bad as well. So we've got dy dx is equal to, so it's that because the squared isn't there, the whole thing isn't being squared now, it's just that the x in there is being squared. So the differential of tan is sec squared anyway. I'll just come back up to the top again. So these are in the log terms as well, so you won't have to remember that, but you'll probably forget tan anyway because you won't really be using that as much as sin and cos. You'll remember the sin and cos ones soon enough because you'll do it so many times. So it's sec squared of x squared, but then multiplied by the derivative of what is inside, so that's going to be 2x in this case. So our final answer is 2x sec squared of x squared. And then last one. Right, so here hopefully you'll have seen that you're going to use product rule because you've got two things being multiplied by each other. So that's going to be u, that's going to be v. So u dv dx plus v du dx. So u is just x plus 3. dv dx then, so the differential of sin x will just be cos x. So just put in cos x there. Plus v, which is sin x. And du dx, so the differential of x plus 3 will just be 1, because 1 times 1 is 1, the 3 has gone away. So just 1. So that's it then. X plus 3 times cos x. You could multiply the cos x by both of those things if you want, but you don't really need to. Plus sin x. So that's it. That's differentiating trigonometric functions.